Hey everybody, Mr. Quick here. Today we're going to be looking at Engage New York Math / Eureka Math, Module 2, Lesson 14, Converting Decimal Division into Whole Number Division Using Fractions. Okay, that sounds complicated and that is a long title, but it's a pretty simple concept. So we're taking decimal division, meaning we're dividing decimals, something like maybe 25.2 divided by 5.1. We're going to convert that into whole number division where we can actually have just two whole numbers, and we're going to do that using fractions. So I know that sounds complicated. Once you see it in action, I'm confident that you'll think, oh, okay, I get this. And if not, of course, you can always ask me and we can always talk about it face-to-face as well. But let's go ahead and jump into a couple of examples. Okay, our first example is 25 and 2/10 divided by 72 hundredths. 25.2 divided by 0.72. Now, at the heart of what we're looking at today is knowing that every division problem can be looked at as a fraction, and every fraction is in and of itself a division problem. So we can look at this, instead of looking at that in kind of like the standard algorithm way, we can write that as a fraction. 25.2 over 0.72. Now you might be saying, well, isn't this a whole number and then a part of a whole? Isn't that what a fraction is? It is, but we're ultimately not going to have any decimals involved in our fraction, because what we're going to do is we're going to move these decimals out of the way. Now to do that, we're going to multiply by another fraction. Now we only need to move this decimal one time, 25.2. If you move it one place value to the right, we would have a whole number, 252. But if we only moved it one time to the right, then we'd have to also do the same thing to the denominator, and we'd have 7.2, which gives us a problem in that we still have a decimal in the problem, and we don't want a decimal in the problem. So what we're going to do to move this two times, we're going to multiply it by 100. That's going to give us 0.72 times 100. Move the decimal twice. That's going to give us our new denominator of 72. Since we're multiplying the denominator by 100, we've got to do the same thing up top, so we have to also multiply the numerator by 100. That means we're going to move the decimal twice to the right. That gives us 252, but that's only if we move it once. We're actually moving it twice, so we have to add a 0, so that gives us 2,520. Now you may say, all right, well, what's the difference here? I mean, we have a much bigger number. The fact is that this fraction and this fraction are equivalent, so they will have the same answer. So now we've given ourselves basically just a bigger problem, or bigger numbers, I should say. The same digits, but we're going to multiply this using whole numbers now. Easy for me to say, right? So using that same problem, that same logic, we had our 2,520 divided by 72. And now we have what is essentially just a very simple long division problem. Same thing that we did in the previous lesson, lesson 13. Let's take a look. Okay, I know I'm going to need the some multiples of 72. So I know I have 72 times 1 is 72. 72 times 2 is 144. 72 times 3 gives me 216. 72 times 4 gives me 288. 72 times 5 gives me 360. And I can stop there, because if I need to go farther, I can, but I'm not going to do that right now. Okay, so 72 does not go into 2, obviously. It does not go into 25, obviously, but it does go into 252. 288 is too high, so we're going to go to our next one down, which is, it goes 72 times 3. 72 times 3 gives us 216. We're going to subtract. We can borrow here. 12 minus 6 is 6. 4 minus 1 is 3. 2 minus 2 is 0. We bring down this 0. 72 goes into 360 exactly 5 times. We put our 5 up here. 5 times 72 gives us 360. Subtract that. 0, 0, 0. We're all done. So our answer becomes 35. So going back, 25.2 divided by 0.72 equals 35. We used equivalent fractions to get there, but the answer is still the same. All right, let's jump into our next example. We're looking at 2,000 divided by 3.2, or 3 2/10. Now, again, with the understanding that every division problem can be looked at as a fraction, and every fraction can be looked at as a division problem, let's write this as a fraction, shall we? So we have 2,000 over 3.2, right? If we have 1 over 2, we know that's 1 divided by 2, which would give us 0.5, okay? So that's a simple, kind of a simple way of looking at it, but that is looking at it as a fraction as a division problem. Same thing here, 2,000 over 3.2. We want to make this 3.2 into a whole number, meaning move the decimal one place so we can have 32. So to do that, we're going to multiply. If we don't need to move the decimal one place, that's one place to the right. So we're going to multiply by 10, moving the decimal one place value to the right. 3.2 times 10 is going to give us a new denominator of 32. If we do something to the denominator, we have to do it to the numerator. So we're going to also take that times 10. 2,000 times 10 then becomes 20,000, right? Because we can do 2 times 1 and then add 1, 2, 3, 4 zeros. So now we have 20,000 divided by 32. I'll write that in our algorithm. And I'm going to go ahead and do 32 times 1 is 32, times 2 is 64, times 3 is 96, times 4. And what I'm doing in my head right now is I'm saying 4 times 30 would be 120, 4 times 8 would be 8, so 128, times 5, 5 times 30 would be 150, 5 times 2 would be 160. You can also count up by 32 every time. If the question allows you to use a calculator, you can do that as well. But I just wanted a little bank of multiples there so I can use it, because I'm going to need it right now. Actually, I can already see, I'm looking here, I'm saying 32 does not go into 2, does not go into 20, but it does go into 200. So now I need to add a little bit more over here because 160 is not going to be enough. 32 times 6, 6 times 30 is 180. 6 times 2 is 12. That gives me 192. So that's where I'm going to go. 6 times 32 is 192. I can subtract that. I know that's going to be 8, right? Because there's 8 difference between 192 and 200. Bring down a 0. 32 goes into 80. Well, 3 is too high because that's 96. So I'll go 2 times. I'm going to make a little space here. 2 times 32 is 64. I'm going to subtract, end up with 16. Bring down another 0. 32 goes into 160 exactly 5 times. 5 times 32 is 160. Subtract, we get 0. We're all done. 625. So 20,000 divided by 32 is 625. 2,000 divided by 3.2 is also 625 because those are equivalent fractions. If you look at this and you look at that, this is going to go into this the same number of times as 32 is going to go into 20,000, right? They're both just 10 times bigger. If you think about it in terms of, let me give you just easy numbers, right? 5/10. Erase a little bit here. We have 5/10, and you want to multiply each of those by 10. You're going to end up with 50 over 100. But either way, you're going to get 0.5. And over here, you're going to get 0.5. Because you change them both at the same rate, they're both times 10, it's still 5 ones and 5 tens. Over here you have 5 tens and 10 tens, right? Remember we talked about that when you can look at the number and the place value separately. So that's all I have for you right now. We'll go ahead and do some more examples together in class, but I hope that you're seeing how you can move these decimals by multiplying by fractions. You can manipulate those numbers to make the math easier and faster. There's no such thing as us trying to become mathematicians because that's what you have to be a genius mathematician. That's not how it is. Mathematicians aren't genius mathematicians. It's about knowing how to manipulate the numbers so we can do the math. However we get the right answer, however we figure out how to do it, we can use creativity within math. So anyway, that's all I have for you right now. Thank you for watching, and we'll talk to you in class.